Today on CodeDependent, we're going to talk about the animation class. So in a lot of these episodes, I talk about the effects either in Flex 3 or Flex 4 or Flex in general. And all of these effects are about taking the information that you provide for what kind of animation you want to run, how long is it going to last, as well as information about the target object that it acts on and the properties that you're going to animate. But underneath all of that stuff for the effects, they're actually running a timing engine. And that engine in Flex 3 was called Tween. And in Flex 4, it's called animation. It's a single class that's responsible for setting up an internal timer to call back into the code so that then we can take all the values that you provided to the effects and actually calculate the animated values and then tell the effects what to do with them. So today we're going to take a look at how animation works and how you can use it to run animations at a more simple level. In most cases, it's more appropriate for you to use effects. Effects are there to make it very easy to run animations. But if for some reason you want to run a lower level animation that's not using all of the capabilities of effects themselves, then you can actually use the animation class directly. So we'll see how that works. So let's run a simple application. We've got a red rectangle there. We click on the rectangle and it animates down to the bottom with a little bit of elastic ease there, right? So click animation. We could certainly do this with an effect, but let's see what it takes to actually use animation directly to run it. So here we have our rect defined with a little click handler on the group that wraps it, and we have an animation declared here that says, okay, I've got the following ID. I'm going to be acting on a property animator object. This is another class that I've defined because animation is responsible only for running the timing stuff and calculating values. It doesn't know what to do with those values. So instead, it's going to call back a target object and say, here are the new animated values, do whatever you want to with them. So in our case, we want to take the values that the animation calculates and we want to set them on the rectangle object. And we define this property animator class in order to do that for us. So we'll take a look at that in a second. We're giving it an easer of this elastic ease, which is defined above, that does that little springy effect where it sort of goes past the point and then wobbles around it a little bit and comes to a halt. And it's going to last for 1,200 milliseconds. So some of the properties for animation are exactly like they are with effects. And that's not a coincidence. It's because you supply them to the effect, and then the effect basically passes them down to the underlying animation object. There are two simple motion path objects declared because we're going to be changing both the x and the y property of the rectangle as we move it in x and y. We're going to move, we're going to change the value from a value of 0 to a value of 200 for both x and y. And again, notice that the way you define simple motion paths as this vector of motion paths for animation is exactly the way that you might define it for something like the animate effect, right? And again, you give it to the effect and the effect simply passes it through down to the underlying animation. And in this case, we're actually giving it to the animation directly. So that's the animation, and the other thing that we need to look at then is the property animator object, which is right here. So there is a new interface defined that works with animations in Flex 4 called iAnimationTarget, and it defines the following functions. So when animation runs, every frame that it updates, it gets a callback from the timer, it calculates the current values, and then it calls the animation target functions to pass along the information that's appropriate. So when the animation starts, it'll call this function. When it is stopped, it'll call this one, and when it actually comes to an end, it'll call that one. When it repeats, if you have repeat behavior and a non-one repeat count, it'll call this function. And the most important one is update, and this is where we actually grab the values from the animation and then set them on the target object. So for every frame of the animation, this function is going to be called. We're going to iterate through all of the properties that are in current value, and that's where it keeps the currently calculated values. And we're going to set them on our target object. So when we created our property animator over in this code, we said, okay, we're going to create a property animator with an object of the rect that we defined below, this graphic element that we've defined there. So we passed in the rect object. This gets set as our target for this animator. And for every calculated value in the animation, we're going to say, okay, the property value according to the property value that's been calculated, we're going to say, okay, that property value, in this case it's going to be either x or y, on the target is equal to the currently calculated value that the animation came up with. So that's it. Fairly simple and not that dissimilar from the way things work in Flex effects overall. you have to do a little bit more work because animation runs the timing and the calculation stuff, but the effects actually do the association between the calculated values and the target objects and properties. So if you're going to use animation directly, then you need to take on that step of actually saying, okay, now what do I do with the calculated values? If you want to take a look at this application and other related applications, check out my blog at graphics-geek.blogspot.com.